Starting lesson 5.6, graphing linear inequalities in two variables. Okay, before we were working with equations, now we're working with inequalities. All right, not very difficult. Okay, starting off with example 1, checking solutions. Here is my linear inequality, and I have to check if this is a solution. So I just plug in the x and y values. 2 times 1 plus 9 is less than negative 3. I get 2 plus 9 is less than negative 3. I get 11 is less than negative 3. Is that true? No, that is false. So your answer is no, it's not a solution. All right, going on to the next. Same thing again, x and y. Plug those values in. I have 2 minus 3 times y, which is negative 2, is greater than or equal to 8. So I have 2 plus 6 is greater than or equal to 8. I get 8 is greater than or equal to 8. Well, it's not greater than, but it is equal to. So that's true. And the answer would be yes. Going on to example 2. All right, graphing a linear inequality in one variable. Okay, first thing you do is just imagine there's an equal sign there. Okay, y is equal to 2. How would you graph that? That means that all the points on the line have a y value of 2. That'll be all of these here. All right, now there's two questions you have to ask yourself. It says less than or equal to. So if there's an equal sign there, that means it's a solid line. If there was no equal sign there, then it would be a dashed line. All right, then it says less than. Okay, so is less than above the line or is it below the line? It's going to be below. All right, so you would just color this all in. All right, so what does this mean exactly? Any point I choose from this area, doesn't matter where I choose it, as long as it's in this shaded region, if I plug it in here, it's going to be true. All right, let's graph another one now. Okay, example 3. I'm going to add x here. I get 2y is greater than x plus 2. I have to have it in slope-intercept form. That's my goal. I'm going to divide by 2. Have to divide 2 into both parts, so I have a half x plus 1. Okay, now I have my important pieces of information. Here's my y-intercept. Let's graph that. Now I have my slope. I go up 1 over 2, up 1 over 2, up 1 over 2, down 1 back 2, down 1 back 2, down 1 back 2. Okay, now you have to ask yourself, oh, I wrote an equal sign there before. That should have been a greater than inequality. Okay, so now it says greater than. It doesn't say greater than or equal to. So since there's just a greater than and there's no equal sign, I'm going to have a dashed line. All right, then it says greater than. All right, if it's greater than, you're shading above the graph. All right, if it said less than, then I would shade below the graph. All right, and that's all you're doing here. And then we're done. All right, example 4, modeling with mathematics. You can spend at most $10 on grapes and apples. Oh yeah, the good stuff. All right, and grapes cost $2.50 per pound, apples cost $1 per pound. Write on a graph inequality that represents the amounts of grapes and apples you can buy. Identify and interpret two. Okay, so let's see, we'll call X the pounds of grapes. We'll call Y the number of pounds of apples. All right, so I know that 250 times X is the amount I'm paying for grapes, and then 1 times Y is the amount I'm paying for apples, and that has to be at most $10. So what does at most mean? It means it has to be less than or equal to $10. You can't go beyond $10. All right, so there's my inequality. I got that now. Now I'm just going to isolate y so I could graph this inequality. All right, and all right, let's graph it. So I'm working with 2.5 for the slope. All right, so I'll call each one of these 1. All right, this is, let's see, I got 1, 2, 3, 4, 5, 6, 7. I'm going to go all the way up to 10. Add a couple here, 8, 9, 10. All right, so that's where I'm starting from. And that's going down 2.5, right 1. Okay, down 2.5, right 1. That's right here. Down 2.5, right 1. Down 2.5, right 1. And down 2.5, right 1. All right, there's my line. And it's a solid line because there's an equal sign. All right, and it says less than or equal to, so I'm shading everything under the graph here. But this is a real world problem, so I'm just concerned about what's being shaded within this triangle here. Because you can't use any negative values because you're not going to have negative pounds. So I could choose any values in here I want. I could choose, say, this one. And I could choose, say, this one. And they'll all work. All right, so like, for example, 3, 1 or 1, 3. I could choose 2, 1. All right, you plug those into this equation here, and it will be true. All right, the total will work out to be less than $10. So that's interpreting your two solutions. All right, the important thing is that you know how to come up with inequality and you know how to graph it. All right, if you have any questions, please let me know. Begin the assignment at the bottom of the webpage.